going. You're going to want some paper and a pencil today to take some notes. We've been in the rational expressions, the rational, whereas there's, like a polynomial over a polynomial is a fraction, 2x squared minus 9 over x squared minus 2x plus 1, some rational expression. And today we're going to learn to solve those for x. You're like, oh my goodness, I thought it was bad enough just trying to simplify them. Yes, yes, we've simplified. We've looked at discontinuities, which are holes in the graph. We've looked at asymptotes of the graph. But today we're actually going to talk about how to solve them for x. Now, the good news is the ones we're solving are not nearly as complex as the ones we've been looking at the graphs of. The graphs are a little more complex. We're simplifying it enough just to learn the basics of how to solve them. We're gonna use some smaller equations for that. In fact, the ones we start with are going to be elementary school equations, pretty much, because we just want to understand the concept, and then as we get through the lesson, it'll make it a little trickier, just to kind of ramp up to show that we're algebra students and not elementary school students. So that's what we'll be looking at today. So yes, you'll want a pencil and paper so you have some examples, because you can use it on the assignment, you can use it on the test, you can use it on the semester final even. Take the semester final. Um, so your notes are always gold in this class. So you may use them on the exam and everything. So you would like to have some when the test comes around. The lesson's not that long, so we'll try to get as many examples written down as we can for you, just so make that easy. All right, looking at our grade screen just to check where we're at. Okay, everything done, matrices. We should have the first 3 lessons turned in, and we should be ready for the last lesson. Next week will be the test. We'll be testing over these rational equations next week. But today we're looking at 6.04. So let's go back to the activity screen. Oh yeah, we're getting down to the bottom. And there's a video here, but it hasn't been loading. So I think something happened. Oh, it loaded today. Oh, okay. It didn't load yesterday. I couldn't get the video to pop up at all. So we'll see what this is.
Tom and Huck's family just moved into a new home. Tom and Huck each got their own bedroom in the basement, along with a shared area in between. All 3 rooms, the 2 bedrooms, and the shared area, are the exact same size. Tom paints his room blue to match his comforter. It takes him 2 hours. Huck paints his room green to match his laptop. It takes him 3 hours. They decide to paint the shared room together, but how long will it take? It must take less than 2 hours because Tom can do it alone in 2 hours, but Huck is helping him. You can solve the problem by first thinking about what happens in just 1 hour. In 1 hour, Tom can paint half the room because it would take him 2 hours to paint it all. Similarly, in just 1 hour, Huck can paint 1/3 of the room, but you don't know how many hours it will take with them working together, so call the number of hours X. If you add the amount of work that each of them can do separately in an hour, you find the proportion of the room that they can paint in 1 hour. So you can write 1/2 plus 1/3 equals 1 over x. Because this equation has an unknown in the denominator, it is a rational equation. Do you know how to solve it?
All right. So it has introduced our lesson with this little real life type situation where they're trying to paint a room. Let's go down here and see what we got is. Type the missing number in each box to complete the equation. All right, let's start our notes. So I'm going to switch over to my screen here. All right, you see on the screen a basic. This is a very, very basic because we have an x in a fraction here. In a polynomial. X over 2 equals 3 over 2. So in the chat, what do you think x equals? X over 2 equals 3 halves. So x would equal what? This is a very, very, very basic rational expression because we have a variable in the numerator in here. So looking at that, in order to make those equal, I could also just do this. What over 2 equals 3 over 2? So yes, x must be 3 because the only thing that equals 3 over 2 is 3 over 2, right? If this is just a blank up here, 3 halves equals 3 halves. Well, that makes a lot of sense. Even in elementary school, that makes sense. Got to go back to the very, very basics. That's what our lesson's doing. It's starting out with the very, very basics. What over 2 equals 3 over 2? Well, that would be 3 over 2. It's like, Mr. Brock, I thought it was a trick question. How about this one? Blank over 7 equals 9 over 7. I could put an x over 7 equals 9 over 7, or we could leave it a blank, whichever way you want it to do. But x equals 9 absolutely is that simple. Submit that. See, 9 over 7 equals 9 over 7. How about something maybe a little more complicated? I'm going to make this a little larger on the screen. You can see this. Something, we could call this x over 17 plus 1 over 17 equals 8 over 17. All right, put that in the chat. What would go in that box? Something 17ths plus 1/17 equals 8/17. Now, the secret to remember, and it's been a while probably since you've been adding fractions, you have to have the same denominator in order to add fractions. Well, we do. We have 17 as the denominator in both of these fractions. And so when you have the same denominator, you just keep the denominator and add the numerator. So absolutely, you guys have got it. 7 plus 1 equals 8. Oh, this is great, Mr. Brock. Can this be how the test is? Just 7 plus 1 equals 8? Well, the concept's the same, even if the equations get a little bit trickier. This is the concept we're looking for. This is how you solve them. We may have x's or x squareds or something to deal with, but as long as we understand the basic principle of what we're trying to do, we're trying to make the left side equal the right side, which means if the denominator is the same on both sides, then the numerator just needs to be the same. Here's another one. This is the subtraction. Something over 6 minus 1 over 6 equals 2 over 6. What could that possibly be? Yes, this is not a trick question. This is not a hard thing. We're doing it with some very, very simple fractions just to illustrate how it works. Truman's got it. Since they're both sixes, all we have to do is make sure the numerator works. Something minus 1 equals 2. 3 minus 1 equals 2. So it's 3/6 minus 1/6 will equal 2/6. Perfect. Absolutely correct. All right. That was the fourth and final one to do there. All right. So now you understand the importance of having like denominators when you add or subtract rational expressions. Like, x over 17 plus 1 over 17 equals 8 over 17. Since the denominators are the same, just concentrate on the numerator. X plus 1 equals 8. And then it's easy to see, oh, that solution is x equals 7. And you guys nailed that. If the denominators had not been the same, you would multiply both the numerator and denominator by some number to create identical denominators. And we'll look at some examples where we need to do that. So our questions we're going to learn today. What reasons justify a solution to a rational equation, and how do rational equations apply to the real world? So rational expressions, as a reminder, is something that looks like this: 5x plus 35 divided by 5x. That's a rational expression. Or it could be x squared plus 6x minus 27 over x plus 9. That's also a rational expression. So that's just a reminder of what we've been working with. And the difference between an expression and an equation is if it has the word equation, it should have an equal sign. Equation equal. So like 3 over 8x equals 6 over 4x minus 1. That's a rational equation. And we can solve that to find out what x is equal. Okay, on this one, two different denominators. So let's look at what they're doing here. So they have an expression that's 2 over x equals 3 over 4. Okay, so let's divide that up. 2 over x equals 3/4. You're tempted to look at that and say, well, x equals 4, right? So they're both the same. But then it would be saying 2/4 equals 3/4, and that's not right. That is not equal. 2/4 does not equal 3/4, so x does not equal 4. So to find out, it says we need to have the same denominator. So after I show you their method, I'll show you a shortcut on this, actually. To have the same denominator, it would be multiply those together, 4x. 4x could be the same denominator if they both were 4x, right? That would be, okay. And the way to get 4x, we've already got x over here. So if we multiply by 4 divided by 4, now, can I legally do that? Can I multiply by 4 over 4? Am I changing the equation in any way? I mean, think about that. If we're multiplying this by 4 over 4, does that mean we have to multiply this by 4 over 4? If you stop and think about what this equals, what is 4 over 4? What is 4 divided by 4? Well, that's 1, all right? 4/4 equals 1. So I'm multiplying this by 1. That doesn't change anything, multiplying by 1. So if I multiply this side, 4 times 2 is 8. 4 times x is 4x. Okay, I've converted 2 over x to have a denominator of 4x by just making it 8 over 4x because I multiplied by 4 over 4. This side, I also need to get to 4x, which means I can multiply this by x divided by x. Again, what is x over x equal? You're like, well, what is the value of x? It doesn't matter what the value of x is. If it's x equals 10, it's 10 over 10. If x equals -3, it's -3 over -3. X over x also equals 1. So again, I'm just multiplying this by 1. 3 times x is 3x. 4 times x is 4x. So now I have a new equation that have denominators that are equal. So now we're back to this concept. If the denominators are the same, the numerators just have to be the same. Well, let me set those to be the same. 8 equals 3x. These have to be the same. Divide by 3. So x equals 8/3. That's how that works. And we're like, well, is 8/3 correct? Well, let's test it. The original equation is right here. 2 over 8/3 equals 3/4. Like, Mr. Brock, how do we simplify? Is that equal to 3/4? When you have a fraction inside of a fraction. You simplify it by multiplying it by its inverse fraction. I'm multiplying this. 3/8 over 3/8. 8/3 reversed is 3/8. You're like, I can do that? Again, what is 3/8 divided by 3/8? It's 1. I'm just multiplying by 1. Over and over, I'm multiplying by 1 in this equation. 4 over 4 is 1. X over X is 1. 3/8 over 3/8 is 1. And multiplying by 1 does not change anything. So when the bottom, when I multiply 3/8 times 8/3, the 3's cancel out, the 8's cancel out. This is just a 1. It changes the denominator to 1, which means it goes away, right? Because 4 over 1 is just 4. We get rid of the over 1. 2 over 1 is just 2. So 2 times 3/8 over 1 is just 2 times 3/8. What is 2 times 3/8? Well, this is 2 over 1. And when you multiply straight across. So this is 6/8. 3 times 2 is 6. 8 times 1. 6/8 equals 3/4. Wait a minute. 6/8 simplifies to 3/4. 3/4 equals 3/4. It does check. 8/3 is actually our solution for 2 over X equals 3 over 4. X equals 8/3. Now, I told you there was a shortcut. There is a shortcut because if we have, I'm going to box this out, 2 over X equals 3 over 4. Okay, there's something that students love to do all the time when they see something like this, and sometimes that doesn't work mathematically. Cross multiplying. Cross multiplying. This is actually a situation when you have a fraction equal in another fraction. This is when cross multiplying is actually applicable. We can actually do this. If we multiply this denominator times that, and this denominator times that, 3 times X equals 2 times 4. Wait a minute. That's what we had up here. 3X equals 8. That's what we got to after all of this work. It's simplified down to be 3X equals 8. This was a shortcut, jumping straight from that to the 3X equals 8, which means X equals 8/3. Like it. Cross multiplying. And let's talk about why cross multiplying actually works. It's like this was trying to get the same denominator, but what if we just wanted to eliminate the fractions? If we want to eliminate 2 over X where it's not a fraction, we can multiply by the X, multiply by whatever's on bottom of the fraction. So if we multiply this times X, we also have to multiply this times X because that do the same thing to both sides so we don't change it. What is 2 over X times X? Well, the X's cancel out and this side's just 2. And this is 3X over 4 because I multiplied this side by X. But now I want to get rid of this fraction. How do I get rid of this? I multiply it by 4, which means I have to multiply this by 4. So if I multiply this by 4, these cancel out. This is 8. This is just 3X. That's what cross multiplying is doing. You're multiplying by the denominator on both sides, which cancels out on one side and not the other. Then you're multiplying by the other denominator, which cancels out on the other side and not the first side. So 4 times this side, X times that side. Cross multiplying, what you're doing is just eliminating the denominators for each side. That's how you get to that shortcut to just equals 3x equals 8, or 8 equals 3x, same thing. So cross multiplying is our friend with rational expressions. Oh, love a good shortcut, right? Here's how they did it. They said, okay, we need to get 4x on both sides. So multiply 4 over 4 and x over x, like we looked at, to give it 8 over 4x equals 3x over 4x. And now they're actually cross multiplying. Oh, I think that's funny. They said, hey, we can just cross multiply since we have these equal. I don't know why they didn't think to do it back here then. If they're going to cross multiply, they could have done it right here. But they made the same denominator and then cross multiply instead of just setting 8 equals to 3x. I don't know why they did that. Well, here they break down how you can cross multiply and why that works, which we looked at. So they got 32x equals 12x squared. And then they factored that because now they've got a quadratic equation. So the greatest common factor, they pull out an 4x and 3x minus 8, set those equals 0. In this case, they got x equals 0 as the solution and x equals 8/3 because they made a quadratic equation and factored it. But when you test it, x equals 0 cannot work because that'd be 2 divided by 0. So this is an extraneous solution they got. Extraneous solution is a solution to the equation that actually does not meet the requirements of the original equation. So you can end up with extraneous solutions if you, depending on how you solve it, because they solve it with cross multiplying after making the denominators the same. But the other equation did work out just like we tested. 6/8 equals 3/8. 3/4, which means 3/4 equals 3/4. So there's a possible shorter method. Now they're saying when we have the same denominator, we can just set the numerator equal to each other. 8 equals 3x. It's like, yeah, I don't know why they didn't do that first time. But x equals 8 over 3. All right, this is a pretty short lesson, so we're going to do all the examples here. Now, here's a big thing, writing rational equations from real-world scenarios. And I know we have one of these in our assignment, and I think there's one of these in our test next week. So let's look at some examples. The math club at school is 70% seniors, and the remaining are all juniors. So it's just juniors and seniors in the math club. The seniors number 5 more than twice the number of juniors. Okay, how is that as an expression? 5 more than twice. How many juniors and seniors are there in the club? All right, so how would we work that? How in the world does this work? So it said 70% seniors. So if we're setting up an expression or an equation to solve, we have 70% seniors, which means 30% juniors, right? 70 over 30. We don't have to put the percentage signs. We're just writing an equation. Think of this as a ratio, 70 to 30. There's 70 seniors when there's 30 juniors, 70% to 30%. And we need to set that equal over here to something. So it said the seniors were 5 more than double the juniors. So if we set the juniors equal to x, or however many juniors there are, there's twice as many seniors plus 5. It said 5 more, which is plus 5, than twice the number of juniors. If juniors is x, then seniors are 2x and 5 more. Now look at how we've set this up. This is a rational equation. We've set it up ratios, and the seniors are on top of both. Right? These are the seniors. And on bottom of the ratio, we have the juniors. So we have to be consistent. Senior, junior. Is there more than one way to set this up? Yes, there are different ways to set this up. We could have done the juniors on top. Maybe you want to do 30 over 70. We just have to make sure the other side also has the juniors on top. This is the same. This will solve the same for x. Let's solve this by cross multiplying. All right. Because we can get rid of the 30 by multiplying this by 30, get rid of the x, multiply this by x. So 70x cross multiplying time equals 30 times 2x plus 5. You have to make sure put that in parentheses because it's 30 times all of that. Now let's simplify this. It's just math. It's just the algebra problem. This, we don't even have a rational expression anymore. It's just simple algebra. We have to distribute the 30. So 70x equals 30 times 2x and 30 times 5. So when we get rid of the parentheses by distributing the 30, we get 60x plus 150. Solve for x. 10x equals 150. So what do we know now? It wants to know how many seniors and juniors there are in the math club. What did we learn? We set juniors equal to x. 15 juniors in the math club. How many seniors are in the math club? Well, according to this, twice as many plus 5. 2 times 15 plus 5. Now that we know x is 15, this is 30. There are 35 seniors and 15 juniors in the math club. If we want to test that, is that right? Well, how many students total are in the math club? Add those together, there's 50. It told us the seniors were 70%. 35 divided by 50. Is that 70%? If you're not sure if that's 70%, I'll show you how to test it. It is 70%. Just divide that. 35 divided by 50. That's 0.7, 70%. That is 70%. So the math works out. When we check it, yep, that would be right. If there's 35 seniors and 15 juniors, that means 70% are seniors, 30% are juniors. So taking a live situation and doing the math to figure out exactly how many there are by just knowing 70% seniors and there's twice as many plus 5 than there are juniors. So they set up the variable. Let x be the number of juniors, which means the number of seniors is 2x plus 5. Any other information we need to know? 70% seniors. So that automatically means the other 30% must be juniors. Set up the equation. They said x over 2x plus 5 equals 30 over 70. Like I said, there's more than one way to set this up. Notice that's the other way. I set it up with the seniors on top. They set it up with the juniors on top. But look what happens right away when you start to solve it. You end up with the same equation. 70x equals 30 plus 2x plus 5. And they did it by pretty much cross multiplying. 70x equals 60x plus 50, 10x equals 150, x equals 15. Apply what you've learned. So if x equals 15 means there's 15 juniors, and then 2x plus 5, 35 seniors. All right, let's try another one. See if you can set up the equation for this. So I'll have you set this up before I set it up on the screen. But Kendra is competing in a 2-day fishing tournament. The only fish that count towards her score have to be at least 8 inches long to be considered legal sized. Okay, some little bitty fishes don't count. So on the first day of the 2-day tournament, she caught 16 legal sized fish out of 25 that she caught altogether. So 16 of the 25 that she caught, she could count. The others were too small. So she's starting out on her second day with her sights set on the trophy. Here's the question. And there's more than one question here. So we've got more than one problem. So let's do A first. How many legal sized fish would she need to catch in a row from starting off today to have a 75% success rate overall? Well, let's see what our success rate is right now. Right now, 16 divided by 25. Right now, 64% of the fish she caught count. They're legal. Those are good. 64%. She wants to raise that to 75%. So see if you can set up an equation. I'm going to set up an equation on paper. I'm not going to show you yet. But she's caught 16 fish out of 25. And this may be a little tricky. You have to think about it. She wants to get her rate up to 75% success. I'll show you how I'm doing this. Put some thought towards that. I haven't finished it, but I've started it. Right now, she's got 16 that are good out of 25 she caught. She wants to be 75%. It's not. It's not 75% yet. So, how many more would she need to catch plus some number? But if she catches, let's say she catches 4 more. She catches 4 more. So now she's got 20 that count. She'd also have to add that down here. That's total fish she's caught. So however many more she adds has to be added to the total number legal and the total number caught. So she wants the numbers she's caught divided by the total number that the amount she's caught that she can count, total number to equal 0.75%. So that's how we can set that up, which this is just 0.75 over 1. Well, let's look at it a different way just to make this clearer. Just make this clearer, because just doing it that way may a little confusing, because that's not how we did the other one. This would be 100% of the fish she caught. She wants 75% to equal the amount caught. Set it up that way. Legal fish, 75%. Total caught, 100%. Okay, let's try solving that. I'm going to do it too. I'm just going to do it a little slower. Got you good ahead of me. Start out by cross multiplying. Multiply that. Multiply that. I'm going to do 100 times 16 plus x equals 75 times 25 plus x. Probably going to need a calculator. Not the first one. 16 times 100. We can do that. And then 100x. Remember, you got to distribute when you have the parentheses. I want to pull up the calculator for the other one so we don't make any mistakes there. 75 times 25. That's 1875. plus 75x. So multiplying the 75 by everything in the parentheses. Now I just need to solve for x. I've got it down to just a basic algebra problem. I'll subtract 75x from both sides, which gives me 1600 plus 100 minus 75. Another side, 1875. Subtract 1600. 1875 minus 1600. Now all I have to do is divide. 275 divided by 25. 11. If the first 11 fish that she catches, 16 plus 11 will be 27. If the first 11 she catches are all legal size, 25 plus 11, she should have 75% of the fish she caught count. So that'd be 27 out of 36. 27 divided by 36 is 75%. So she needs to catch 11 fish in a row starting day 2 to have her overall percentage at 75% of the fish she catch, she can count. Okay, that gives us a good sample of how to do it. Here's the 75%. X would be the number of legal size fish caught on day 2. 16 over 25 was day 1. So if she adds day 2 to it, X over X, however many, she wants to get 75 out of 100. So 16 plus X over 75. 16 plus X over 25 plus X equals 75 out of 100. Cross multiply, X equals 11. So now that you have that example, what about having a 90% success rate? 90% success rate. Only one thing has to change in that problem. Everything else should be exactly the same. I think you're going to have to catch a lot more fish. All right, work on 90. I'm going to wait for a second, let you get a head start. I'm going to write the problem over here. Make sure you at least have it set up properly. Start. I'll put what I got. There's the setup. Looks a lot like the last one, but instead of 75%, she wants 90%. Otherwise, it's the exact same problem. We're just looking for 90% success rate this time. All right, are you working that? Are you ahead of me? I'm going to cross multiply. If you get X, put it in the chat there. I'm pausing to see if you get it before I do. Oh, Braylon's already there. That's a lot of fish got to catch. I figured to get to 90%, that'd be a lot more fish. All right, I'll do the next step. 16. This side didn't change because it's still the 100. 90 times 25. If you don't have a calculator out, I'll get that number for you. 90 times 25 is 2250. Plus 90x. All right, how you doing? Pausing to let you get ahead again if that slowed you down with that 2250. Solving for x, I'm going to subtract my 90x. You could move the 1600 first or the 90x. It doesn't matter. 1600 plus 10x, 2250. Move the 1600. 10x equals 2250 minus 1600 is 650. Absolutely. Breland had it nailed. She's on top of that. Let's check it to see if that's right. 16 plus 65 over 25 plus 65. See if this is 90%. 65 plus 16. So 81. 25 plus 65. So 20 plus 60 is 80, plus 5 plus 5 is 90. 81 out of 90. 0.9 or 90%. Let's see. Just for those of you, 81 divided by 90. It is 90%. But she'd have to catch 65 fish in a row that are all 8 inches or longer. She's not going to make 90%. That's crazy. There's going to be some small fish caught in there. And she only caught 25 fish the first day. I don't think she's going to catch 65 on day two, unless she's cheating somehow, using one of the dynamite to throw it in the water, right? 90%. Got to catch 65 legal size fish in a row on day two. Okay, let me ask this question. How about 100%? Could she get 100% success for the overall tournament? How many fish would she have to catch on day two to have an overall 100% success rate? Have you thought about that? It's impossible because she's already caught some fish that don't qualify. She'd have to go back in time and redo day one and not catch any small fish. 100%. It says it took 65 fish to get it to 90, right? 65. It's not possible to get to 100% because she's already caught fish on day one that were not legal size. So even if she caught 1,000,000 fish, her fraction be 1,016 divided by 1,025, and that's still not 100%. It's really, really close. It's a 99 point blah, 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 but it's not going to be 100 because your numerator will never equal your denominator to get 100%. How about a 60% success rate? We said already she was at 64%. So she would have to go the opposite direction, catching some smaller fish to decrease her success rate. We could do the same thing. We just add more to the bottom, really. The Y, her new success rate. She needs to catch some more. She don't need to catch any more legal size ones, but she wants to bring it down. So they do the calculations there with just taking the Y off the legal size because she's already higher than 60%. And that'll let you know that 9 more would bring her rate down. 9 more would bring it down to a success rate. Less than. Oh, that's just less than. It's not even at 60%. Below, drop below. So that's a less than because you didn't want to be 60%. Anything below 60% is fine. So, all right. Lesson summary already. We'll do some example problems on the next page. Solving rational equations. Find a common denominator. Simplify the equation. solve for x, check your work. And then, like they had that first one that they had an x equals 0 that they had to throw out as an extraneous solution. Okay, let's look at the practice problems they provide. Solve each rational equation on your own. When you're done, check my work. 6x equals 10 over 15. Those are really small. Let's make that bigger. 6 over x equals 10 over 15. I just cross multiplied. 10 times x, 6 times 15, 10x equals 90. So x equals 9, right? Divide both sides by 10. 6 over 9 is the same as 10 over 15. That is 10x equals 90, x equals 9. Oh, does this tell you how to do it? Oh, no, it just tells you the directions. Okay. 1 over 2x minus 1 equals 3 over 9. That's not bad because there's just a 1. So when you cross multiply, I'll cross multiply this first. 3 times 2x minus 1 equals 1 times 9. 3 times 2x is 6x. 3 times negative 1 is negative 3. Add 3 to both sides. 6x equals 12. So x equals 2. Right? X equals 2. There you go. They have one more. I will leave that for you to work. So, because you can check your work right here. They got the answer for you. So I'll let you do that one. Let's look at the second one here. This one, they just want us to create the equation. You do not need to solve. Just see if we can set it up, because that's the hardest part, is setting this up. Oh, this looks just like a question that's on the test, because I looked ahead at the test next week. This looks a lot like it. In the aquarium, 90% of the fish are blue, and the rest are red. Okay, let's start that. 90 are blue, and the rest are red. So we're putting blue on top and red on bottom. We could do the other way. You just have to be consistent. So I need to put blue on top and red on bottom on the other side of the equal sign. The blue fish are 10 more than twice the red fish. So that means the red fish, we need to make x. And it says twice the red fish plus 10. 10 more than twice the number of redfish. You could do 10 times 2x. That's the same thing, but generally we put the x first. So 90 over 10 equals 2x plus 10 over x. Let's see how they did it. That's all he wants to do is just set this up. Okay, they did the redfish on top. It's still the same. Both sides are still equal. As long as you have red on top on both sides, x and 10 would be the numerator. That's the same as having this as the numerators. It'll still solve to be the exact same x when you cross multiply. So it would be correct either way. They have a second one. Create a rational equation. Keenan's playing on the soccer team. His team has won 7 games out of the 12. 7 out of 12. This is just like the fish example we just did. How many games do they need to win in a row to have an overall success rate of 65%? Right now, There's 7 out of 12. They're at 58%. So how many games do they have to win in a row to bring that up to 65? That works exactly like the fish one we just did. And all they have to do is you just have to set it up. They just want you to set it up right. Right? All right. That is all of that. If you look at page 4, it just says do the work, take the quiz. Here is the assignment. The laundry has been sorted into dark clothes and light clothes. The number of dark clothes is 3 more than twice the number of the light clothes, and the laundry is 60% dark. Which one of those is the proper equation to set up that scenario? So it's like we were just doing, trying to set up the equation based on what we know. Here's one to solve. 6 over x equals 4 over 8. Cross multiply. Here's a 2 over 3 equals 8 over x plus 6. Cross multiply, solve for x. 5 over x equals 4 over x plus 3. Those are just like the examples on page 3. And here's another one, word problem. Tennis team has played 28 matches. They've won 10. How many do they need to win to have a 55% success rate? Right now, they're 10 out of 28. They're only 35%, pretty low. They want to get to 55. You have to win quite a few games in a row. How many? All right, guys. Wrapped up early today. That means you got time to hopefully get these 5 done before your next class. So I will give you that time to work on this assignment. If you want to hang around, if you think you have questions, I'll be here. Otherwise, go have a great week, and we'll catch you next time.